Welcome friends again. So here we shall demonstrate the procedure to draw the development of a cylinder. So we have previously seen the development of uh, the prism as well as the pyramid. In case of a cylinder, it is actually very simple, straightforward. So we need a sheet, a rectangular sheet basically, to make a cylinder. So that is to be folded. And what will be the dimension of that sheet? The height will be equal to the height of the cylinder, and its length should be equal to the circumference of the cylinder. So in this case, you note the diameter of the cylinder is 8 grid spaces. That means 2 AutoCAD units, or in millimeters, according to our scale, it is 200 mm. So the length of the circumference, so for getting the length of the circumference, so we can simply multiply it with pi. So the diameter is 2 AutoCAD units. The diameter is 2 here I will take 2 AutoCAD units, multiply it with pi, and I get 6.283 AutoCAD units is the circumference. So what we can do, so a line I can make, so from here at 6.283 AutoCAD units, and angle is 0. So that way a line I make, and then I draw the vertical from here using F8, and then I connect here like this. So the development is basically complete. But many a times we will need to transfer some profile also along with this development. If there is a profile on this cylinder, let us say, so I have some triangle here. If this is to be transferred onto the development, then so I need some points. So to transfer those points, so when the curves are involved, so we need the concept of generators. So what you see, for that we believe that, we assume that there, of course we know that in a cylinder we have infinite number of vertical lines along the circumference like this. Only the lines at the extreme are visible due to tangency, but rest of the lines are not visible. So what we do, so few of the lines we assume, so few of the lines we shall take here. So we use the polar array, and let us say, so we will have 12 number of total number of items, and angle to fill. Angle to fill is 360. So we have 12 number of generators spread like this around 60 degree. So the object is this one. So it is to mark the points of the generators, and the center point is center of the circle like this. So we get the 12 number of generators like this showing up here. I can label them. So let me label them from 1 to 12. So here it is the starting point. So this is point 1, 2, 3, then I have the point 4, point 5, 6, 7, 8, then 9, 10, then 11, and finally 12. Since I do not need much distinction between the front view and top view, so I can label the front view points as simply 1, 2, 3, 4, 5, 6 itself. So this liberty I can take only in the developments. Now these points, these generators, so corresponding to these points, the generators I need to draw on in the front view. So corresponding to 1, it is already there. Corresponding to 2, let me draw it here like this. Corresponding to 3, again I will drop the perpendicular like this, and corresponding to 4 again, and that is anyway in the middle, so I can directly draw that. So I can trim the unwanted portion of the generator. This is the generator. I can rest of the generators I can mirror, so I can use the mirror command also. Wherever possible, we should try to exploit the symmetry. So this is how the generators will look like. So this is just an assumption. All of you please remember, please note that these extra lines, these are just assumed lines. So we assume that because there are infinite number of lines, so few of them we have even drawn. It will help us to transfer the points on a curvature so smoothly. So that is the general way. Otherwise, for development, the development is already completed. But now these generators are to be transferred onto the development here. So for that, so what we can do, we can use the polar array. As you know, this length is equal to pi d, and pi d is equal to 6.83 AutoCAD units, or 683 millimeters. So 683 millimeters we have to divide into 12 segments. So we see the calculation here at the top. So it will amount to 52.36 millimeters. So how I can transfer these things quickly on the development, how I transfer the generators quickly. I'll use the rectangular array. So number of columns I need 13, and the it is a single row. So the column offset distance will be 52.36 millimeter, or 0.5236 AutoCAD units. So column offset distance is 0.5236 AutoCAD 5236 AutoCAD units. So the object to be arrayed is this vertical generator, and this will complete the job. So we note, so we had 2, so I removed 1. So this way the generator will be completed. So if I am asked to generate it using or starting with point 1 and in the anti-clockwise direction, I label this generator as 1 1. So I can use the text again. This is point 1 1 2 2. Assuming that I'm starting with 1 1 and I'll follow the counterclockwise direction. So then this will be the labeling: 3 4 5 6, then 7 8 9 10 11 12, and again the last one will be the first one, repeating. Again here it is 1, and the just after that we have 2 and 12, 2 and 12, and after that I have 3 and 11, 3, 11 I take like this. Then I have 4 and 10, 4 and 10, and the next one is 5 and 9. This was so I should actually consider it. Okay, now we note that our the points are labeled, so the generators are all labeled. So we note that the generator number 2 and generator number 12, so they will be overlapping. So just one line here in the front view, so it is representing 2 generators, but the extremes, they represent only 1 generator. So that is why the 2 and 12 are written like this. And so here, so particularly these number of generators, so they will help us in transferring a point or different points, so on the curvature like this. So what we can do, so from we note that there are in total, so starting with this 1, 2, 3 and 4, 5 different points, important points are there. So 5 on the front side, 5 on the rear side. So we know that on the front side the generators are 3, 4 and 5, on which these are there. So from here the height is to be transferred. So first we start with 3, and then we have it on 4. So on 4 we have 2, so directly. So we should try to draw the development exactly in line with the front view, so that the transfer of points is easier. So that this point also we should keep in mind. Then I need to transfer them on 5. On 9 also I need, but that thing, because it is symmetric, so we'll make use of symmetry and we'll be able to get that point. So this is the point, on 3, then 4, then 5. So this is how it will look like. So from here, from here ortho off, you can draw up to 4, and then draw it up to 3, and then draw it up to 4, draw it up to 5 back like this, and then again here. So this is what you will see, and this profile will repeat starting from the 9, 10 and 11. So it will be there on 9, 10 and 11 also. So on 9, 10 and 11, you note it will be in the reverse direction. It will start with in the reverse direction. So I can extend all these 5 horizontal lines up to maybe 11, which is the last one. So I can extend these lines. So just for better clarity, I'll extend them like this. And I know on 11 I have 1 point, so that is corresponding, 11 is corresponding to 3. So this is the point. To clarify, I can mark it using the point PD mode 3 I have used. Again, the other two on 10 are similar to those on 4. So as we have the point on 4, similar way I have it on 10. Again, on 9 it is similar to 5. The location is similar to 5, and this way you can join from this node to this node and to this node. So this will be slightly different than the collinear line. So these construction lines we can remove. The generator lines we can retain. The points also we can retain. We can even transfer them. So you could have even used the point 7 as the mirror. So in this situation you can imagine that so all these things would have been possible just even through the mirror command. So I start with this end to this end of the 7 and we get everything on the development. So this way, so the development of a profile on a cylinder can also be done using the concept of generators. Thank you.